Methods of preparation of haloalkanes. If you're not sure what are haloalkanes and haloarenes in organic chemistry, you can go and check out the shorts which are uploaded in the same YouTube channel. There are primarily 4 methods of preparation of haloalkanes, which is first from alcohols. Alcohols exist in the ROH, where OH is the hydroxy group, which is also known as the alcohol group. Next is from hydrocarbons. Hydrocarbons are chains of carbon and hydrogen. Another method is preparation from alkenes. Alkenes are also hydrocarbons, but here the carbons are doubly bonded. Halogen exchange, which exists in the skeletal structure of HX, represents a halogen. Examples of halogen include chlorine, bromine, iodine, etc. Let's begin with the first method. We are using hydrogen chloride as the reactant, and then the reagent for hydrogen chloride is zinc chloride, ZnCl2. Let's get an example. Let's take methanol. Methanol is written as CH3OH. Meth means one carbon. Methanol in the presence of zinc chloride and hydrogen chloride will give a haloalkane. Let's see which will be that haloalkane. Before doing that, I'll teach you an easy method to solve this equation. Let's put the charge for all these compounds. The carbon has a positive charge and the hydroxy group has a negative charge. Same for hydrogen and chloride. Hydrogen has positive charge and this chloride has negative charge. During the reaction, the positive and negative compounds are going to recombine. Therefore, this hydrogen from hydrochloride will go to hydroxy group of the alcohol and vice versa. This carbon group will go to the chloride negative group of hydrogen chloride. Let's see what is going to be the answer for this one. This will become CH3Cl and the byproduct will be water, H2O. Now let's name this compound. This compound is known as chloromethane. Here, chloro is the halogen group, whereas meth refers to one carbon and ane refers to alkane. Next method is from the same, which is hydrogen bromide. Here the reagent used will be concentrated sulfuric acid. How to write it? Concentrated is written in the short form or abbreviated as CONC, and sulfuric acid is, as we all know, H2SO4. Fun fact, H2SO4 or sulfuric acid is one of the kings of acids. Now let's write a reaction. Ethanol is represented as CH3, CH2 and OH. Same as before, this is the alkane group and this is the hydroxy group. We are going to add our hydrogen bromide in the presence of concentrated sulfuric acid. Let's do again the markings of charges: positive and negative, positive and negative. You need to pay attention to one thing, that all the halogens have the same negative charge. Thus, the Br of hydrogen bromide is a halogen and it has thus negative charge. Now let's do the reaction. Hydrogen will go to the hydroxyl group and the positive part will go to the negative part. CH3, CH2, Br, and the byproduct is water. Reaction using hydrogen iodide. Here the reagent is heat. Heat is represented by a triangle. Then we will write, we have taken the example of methanol. we'll heat the reagent and the reactant and we'll get the final answer, iodomethane. Another method of preparation from alcohols is using the reactant. This reactant is PCl3. PCl3 is known as phosphorus trichloride. Ethanol, CH3CH2OH plus PCl3, which is phosphorus trichloride, we'll get CH3CH2Cl. The byproducts are H3PO3. H3PO3. One thing that you need to keep in mind while writing these equations is that mentioning one of the major byproducts is an important part. Let's get on to the next reagent, PCl5. PCl5 is phosphorus pentachloride. CH3OH plus PCl5 gives chloromethane plus POCl3, phosphoxychloride. Additional byproduct is HCl. Said to be really ergonomic and economically feasible one in industries and commercial purposes for generation of haloalkanes. This is known as thionyl chloride. Thionyl chloride. And the reagent which we are using is pyridine. CH3OH plus SOCl2 in the presence of C5H5n, which is pyridine, we will get CH3Cl, and now the byproducts are the really important one. Sulfur dioxide, which is a gas, and hydrogen chloride, which is also gas.